Hi everyone, I'm Zhuoyan from University of Wisconsin-Madison. I'm here to give a presentation of our ICCV paper, Learning to Inference Adaptively for Multimodal Large Language Models. This is a joint work with Khoi, Preeti, Saurabh, Somali, Yingyu, and Nguyen. The work is done at the University of Wisconsin-Madison. Large language models have been extended to connect visual and textual data. This brings multimodal large language models, which have shown impressive visual capabilities such as image captioning, visual QK, or etc. Multimodal LLM uses an encoder to extract visual features and use a connector to bridge visual and text modality. However, there are critical challenges when we want to deploy them in the real world. Consider a scenario in the top figure. Whether you ask a simple question or a complex one, the model uses 100% compute. There is no adaptation to input complexity. Bottom figure shows the resource constraint scenario. The model cannot adapt when server resources change. When we have lower compute resources, it still runs at full compute with higher latency. The key challenge is that conventional multimodal LLMs have a fixed computational footprint. They don't adapt at runtime. There are certain related solutions, such as model compression, token selection, or MOE. However, none of them can adapt to varying compute budget. We propose our solution AdaLLaVA, a latency-aware adaptive inference framework that dynamically adjusts computation based on both input contents and the specified compute budgets. Here is AdaLLaVA in action. Given the same image and question, our model adapts to different latency budgets, such as 60, 85, and 100 compute. The intuition of our method is to view multimodal LLM as a collection of shallower models. We observe that there are certain redundancies within the model structure. Prior work shows many transformer layers and heads can be skipped with minimal accuracy loss. Based on this, our key insight is multimodal LLMs building redundancy can enable runtime flexibility without retraining multiple models. We present AdaLLaVA, a novel adaptive inference framework for multimodal LLMs. The overall model architecture is shown here. Our latency encoder embeds an input latency budget into a latency token, which is further processed by the early part of the LLM. The scheduler then takes the latency token and outputs an execution plan that controls operations in the remaining part of the LLM. Our latency encoder and scheduler are jointly trained with the multimodal LLM. We evaluate on LLaVA 1.5 and MIFA 3 billion models, training with original LLaVA visual instruction tuning data and testing across multiple VQA benchmarks under different latency budgets. Here we show the main results of our method on LLaVA 7 billion. It enables the original model to adapt to varying compute budgets at inference time while maintaining minimal performance loss. We here show the key capability of AdaLLaVA, its adaptivity to latency budget. We have 3 curves here. 2 of them are our methods and 1 is baseline where we just skip the top layers. We have 2 designs. AdaLLaVA L operates at the layer level, where we skip the entire layer and only keep residual connection. AdaLLaVA H provides finer control, where we only operate individual attention heads and MLP neurons within each layer. Our results show we enable a single model adapting to varying latency budget from 50% to 100%. They show smooth accuracy-latency trade-offs, especially we do not have any latency violation. To summarize, in this work, we present the first adaptive inference framework for multimodal LLMs. We propose a novel latency-aware scheduler design, and we perform extensive validation across benchmarks. Thank you for your attention. Please visit our website for code and more details. If you are interested in our work, please feel free to talk to us at poster session 1, number 300 at ICCV. Thank you.